Okay, this is going to be a lengthier video about reflections and their relationships to perpendicular bisectors. Specifically, when we were in 8th grade math, we did reflections across the x and y axis. Now we're going to do reflections pretty much anywhere in the coordinate plane. So let's start with this triangle here, and I will outline it. And we're going to reflect that triangle over a line. I'm going to keep it relatively easy. I'm going to make it a vertical line, no rotations. Let's change the color of that. Here's our line of reflection, and we're going to reflect that triangle across that line. Before we go any further, I'm going to put in a little bit of information. Let's say this is the line x equals 12 instead of the x-axis. So it's a vertical line in the middle of the plane. And let's say this is the point. Let's make it the point 10, 5. So we're 5 above the y-axis. But this y value really isn't very important other than the fact that it's going to stay the same. Now, so the reflection, hopefully you can guess exactly where it's going to go, but we want to talk about some details. So I don't have a reflection tool. I'm going to have to do a rotation to make it look like a reflection. And there, that should be our reflection across the line x equals 12. And let's highlight that with, how about green? Okay. So first things first, where is this point located? If this was 10, 5 and it's a reflection, then it's going to, if the 10 is 2 away from the line of reflection, then this point will also be 2 away from the line of reflection, but 2 going the other direction. So this should be 14, and for this particular reflection, our y value is going to stay the same at 5. It's almost irrelevant. What matters here is the nature of this line segment and the fact that it is the line of reflection is a perpendicular bisector of this line segment that connects the original shape, the red one, with the transformed or the reflected shape, the green one. For you to have a true reflection, every single point on the original shape must connect to a point on the new shape such that it is perpendicularly bisected by the line of reflection. I know that's a mouthful. The line of reflection is going to be a perpendicular bisector for every line segment connecting an old point to a new point. So here, that's perpendicular, and notice how this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this line segment and this line segment are the same length, and they are perpendicular to the line of reflection. So that is a true reflection there. The line of reflection is a perpendicular bisector. And we can identify the points fairly easily, assuming that's right on the grid mark, and it's close enough, so we're going to say that it is. If the line of reflection is x equals 12, and this point is 5 away from the line of reflection, then that would be 12 minus 5 for 7. So this point is 7, and if we said this one is 5, that'd be 6, 7, 8. But again, the y value is kind of irrelevant here. And then this, we're going to go 5 to the plus side of 12. So 12 plus 5 is 17. So this point here would be 17 and 8. The y value stays the same. So I don't want you to really think of a formula so much. We don't want to think formulaically. We just want to use our instincts and what we see. You want to use what you see. And this definition of perpendicular bisector. So we've got this point out here and this point out here. For it to be a true reflection, the line segment that connects those together must be a perpendicular, or must be cut in half and perpendicular to this line of reflection. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 units here. 1, 2, 3, 4, 5, 6, 7, 8 units here. So this is definitely a true reflection, and we could even identify those points at, let's see, if this line is x equals 12 and this was 8 units, that would make this 20, comma 11, and this one would be 8 units to the left of x equals 12, which would be 12 minus 8 for 4. This would be 4, comma 11 for this point out here.